The last thing that we are going to do with inverse functions is finding the inverse of a function. So let's say that we are given the equation of a function and we wish to come up with the equation of the inverse on our own. We can create the inverse function ourselves by doing these 4 steps. So the first thing that we're going to do with this example is we are going to do step 1. We are going to replace f of x with y in the equation. So f of x equals 4x minus 5. The first step is to replace, wherever you see the f of x, we're going to replace that with a y. So that's a pretty easy step. Not hard to do at all. The second thing we're going to do is also actually pretty easy. We're going to switch the x's and the y's. When we actually switch the x's and the y's, this is actually when we create the inverse. This is actually where the magic happens. The whole idea of an inverse is that the x's and y's reverse themselves. So in step 2, for this example, everywhere I see a y, I'm going to write x instead. And everywhere I see an x, I'm going to write y instead. So we're going to switch the x's and the y's. The next step is actually the most interesting of the steps, and that's to solve for y. We want to get y by itself on one side. So step 3 is actually where a little bit of the work comes into play. So I want to get y by itself, so I want to isolate or get y by itself. So the first thing I'm going to do is any adding or subtracting. So I'm going to add or subtract. In this case, I'm going to say plus 5 on both sides because I'm subtracting a 5 in the equation. We're going to do the opposite of that. So how do I get rid of the negative 5? We add a 5. So then I end up with x plus 5, and those are not like terms, so I can't actually combine them. Those cancel out, and now I'm left with 4y. Alright, the last thing now I want to do is get y by itself by dividing by 4. So remember, we're trying to get y alone. What's connecting y to the thing we want to get rid of? It's multiplication. The opposite of multiplication is division. Whenever I do to one side, we have to do the exact same thing to the other side. So we're going to divide both sides by 4. So we end up with x plus 5, all of that divided by 4, and then the y's cancel each other out, so I end up with y. And that's step 3. Solve for y or get y by itself on one side. Step 4, the last step of the process, is to go back to the f of x notation. But what we want to do is we want to declare that what we've created, this new equation, is different from the original equation that we were given. Remember, what our goal was to create the inverse function. So now we're going to go back to that function notation, but in place of y, I'm going to write f inverse of x. We want to declare loud and proud that we've created the inverse of the original function that we were given. And then on the other side of the equal sign, we'll write the equation that we created. And that is our inverse function. Alright, we're going to do those same steps again for our last example. Alright, step 1 is a really easy step. It's a replacement. So we're going to replace f of x with y. So that's going to look like y. Instead of f of x, I'm going to write y equals x cubed minus 7. The second step is to switch x and y's. So everywhere I see a y, I'm going to put an x, so I have x equals, Everywhere I see an x, I'm going to put a y. So we're going to switch them. Alright, and that's step 2. Step 3 is where the interesting things start to happen. So in step 3, we want to solve for y, or we want to get y by itself on one side. So in order to do this, the first thing I'm going to do to get y by itself is I'm going to do any adding and subtracting that I can do. So I'm going to add 7 to both sides of the equation. I get x plus 7, now those are not like terms, so I can't actually combine them, is equal to the minus 7 and the plus 7 are going to cancel each other out. So we end up with y cubed. Okay, I'm just going to pull this up here. I gave myself a little bit of distance between the equals and the y cubed, and we'll see why in just a second. Now remember, I want to get y by itself. I want to get rid of anything that's attached to y. And so what's attached to y now this time is a cube. How do we get rid of cubes? Well, we want to do the same thing to both sides. And so if I have y cubed, what we're going to do is we're going to do the opposite of that. We're going to take the cube root. Okay, so let's remember why that might be helpful. That might be helpful because underneath the cube root we have 3 y's. If I have 3 y's, that's a group of 3. When I'm doing cube root, if I can find a group of 3 underneath, I can circle it, cross it out, and I can bring 1 y out front of the cube root symbol. But if everything gets circled and crossed out, then the cube root or the radical symbol goes away. So I'm left with just plain old y. And so on the other side, nothing changes. I still have the cube root of x plus 7. So if you see a cube, we get the thing that's being cubed by itself, and then we apply cube root, or we take the cube root of both sides. We simplify by bringing out any groups of 3, and now, as soon as I do that, the y is now by itself. There's nothing else attached to it, nothing around it, just y by itself. Right, the last step is to replace y with f inverse of x. So the last step here would be to go back and say, instead of writing y, I'm going to write f inverse. We're going to use that f notation, that f of x notation, but f inverse, because these two equations are not the same. So we started out with x cubed minus 7. We ended up with the cube root of x plus 7, and those are two opposite things. They're totally different. So we want to declare loud and proud that this is the inverse of the original function that we were given, and it does exactly opposite of that original function.